Welcome to the 6th installment of the Q&E expansion video series. In this video, we are going to discuss wiring for a staging yard helix, and we're going to show you how the sub-roadbed for the visible part of the layout was completed. And if that sort of thing doesn't turn your crank, there'll also be an opportunity for you to participate in a discussion on how the final track layout will be designed and installed. Here is a side-by-side comparison of where we were at the end of our last video to where we are now with the sub-roadbed plywood essentially completed. At the end of our last video, I teased this idea of how to wire up all these tracks in the staging yard by passing the wires between the flex track sections or through the roadbed. There are actually only 4 tracks used for staging in the Helix. The 5th track is the main line that runs to the loop at the end of the line. Because the Helix wraps around itself, and I like to drop feeders for electrical power every second track connection, there are several connections for each of the 5 tracks as they go around the Helix. So with all those wires, I wanted to centralize them to connect them easily to the power bus that I'm going to run through the layout. So I came upon the idea of using these terminal strips to collect all the wires together. Each terminal strip can handle 8 wires, so that's 4 white and 4 red, or 4 positive and 4 negative. And the idea is that they're all connected in common, at least all the whites and all the reds are connected in common, to be consistent with the way I wired up the staging yards on the existing layout. I did this because with DCC you can completely shut down individual locomotives or consists on any given track rather than turning the power off to the track. Now I know there still is some current running through the decoders even when they're not on, but it hasn't really been a problem for me for 20 plus years. To be clear though, I only turn the power on to the staging yards when a train is arriving or departing. Otherwise the entire staging yard is dead. Nevertheless, I use these jumpers to provide that flexibility just in case at some point I wanted to run individual control wires to each track. So here you see I've cut the 8-pin jumper into 2 4-pin jumpers quite easily with the cutters and my pliers. So the first step is to locate the terminal strip in an area that's kind of equidistant to each of the 4 joints that you're connecting the feeder wires from, and these are for the first level of the Helix. So these feeders would have been soldered on at an earlier video that you may have seen. And of course I've numbered each of the wires so I know which track they're going to. And now comes the tricky bit, how to get the wires from the top level of the Helix down to the terminal strip below the first level of the Helix without having the wires be way too long. And here you see the first test fit to see how the wires can be run through holes drilled in both levels of the Helix. And luckily I used a thicker gauge wire so you can get away with roughly 2 feet of run without too much voltage drop. Because of the distances involved with track 0, the main line, and track 1, I opted to run them down more directly and then across underneath rather than zigzagging under the tracks as I did for the other 3 tracks, as you see here, to get to the terminal strip. Once I got the hang of it, it was a simple matter to repeat the same process, albeit in this case using passageways through the cork roadbed rather than using the gaps between the rail sections. The placement of the third terminal strip was a little bit trickier than the other two because it was close to the yard ladder for the beginning of the staging yard. And I had to leave room for access to both install and maintain switch machines at a later date. And the last bit of electrical work that I did here is to install the gaps just at the ends of each of the turnouts to the staging yard tracks. And for these I used O2O styrene strip. If you remember the beginning of this story, we had traced the layout on craft paper that was laid out on the floor of the basement. I had also marked out the edge of the layout fascia as well as the backdrop on the inside of the layout. This is what was used to create tracings that were cut out to be overlaid on top of the plywood to create the final sheets of sub-roadbed to be added to the layout. Since the location of the Benchwork support columns was also marked out on the craft paper, it should come as no surprise that everything lined up perfectly. Well, almost perfectly. The test fit identified a couple of areas that needed some adjustment. A small amount of shaving was required to make sure that the fascia, when it's installed, would be perfectly vertical. This way, both levels of the plywood could be used to mount the fascia. The other minor issue is that I ever so slightly miscalculated or miscut the corner of the plywood by a matter of 1/4 of an inch to get around the door edging. A simple trim job, and it fit perfectly. The second half of the visible area was a little bit more challenging because, as you recall, we actually changed the outline of the fascia to deal with the problem of clearance to maintain a 3-foot aisle to the corner of the basement, and it required us to shift everything by a couple of inches towards the wall. So we had to actually go old school and trace the upper level of the Helix to get the proper shape of the upper level plywood. And here we are transferring that tracing onto the last 4x8 sheet of plywood. During the test fitting, I felt that there wasn't enough clearance to fully open the doors to the electrical panel. So again, a simple trim job to make sure I had enough clearance, allowing for a future layer of the fascia between the door and the layout. This required me to extend the trimming area down through the actual supports to the Helix plywood, but in the end it's fine. It fits, it'll work. With both large sheets of plywood temporarily tacked in place with screws, all that was left was to fill the gap between them, which was a simple matter of a roughly 13-inch wide by 3-foot section from leftover pieces of plywood. As you may recall from our last video, this switching lead or pullback runs through the backdrop on a moderate curve and pokes back into the wall at the end of the layout room. So it needs a little bit of an extension to the sub-roadbed plywood. Scaling off the drawing, I cut a slice of plywood that looks like a slice of fruit and added some splice sections underneath to clamp it to the existing plywood, and then set it off or offset it by about 1/8 of an inch to allow for 1/8 inch masonite, or the future backdrop material, to slide in between them and be held in place. Actually, it's a good way to hold it in place. And so there you have the final extension of the plywood ready to go. This is the missing link, the section, or the final section of plywood sub-roadbed that gets you from the existing layout through the wall to the new section. You see here with the measuring tape, I've just laid out a direct route to see what that would look like. I wasn't too keen on doing that because I didn't want to waste some of that wonderful open area that's meant for access behind the backdrop. If we take a look at our track plan again, you'll see that I had always envisaged kind of an S-curve to run this connecting track along the back wall, thereby maximizing the open space between it and the backdrop, or the back side of the backdrop. It very quickly became apparent that any additional plywood roadbed in this area would conflict with the piece that I had just added for the switching lead. And so I started playing around with the idea of using a combined section here out of another piece of scrap plywood to have both the pullback track and the connecting main line on one piece of plywood. The only catch was that I had to lower the switching lead, or in fact the entire industrial section, by about 1/8 of an inch. So I had to take that off the top of the support columns. I also had to design this piece of plywood to extend through the wall with a plate underneath it that could be clamped or screwed into the existing layout to hold it in place. So here you see the final piece, combined pieces I guess, and next to it is the long narrow section that holds the main line and connects into the new extension at the top of the Helix. At the time this photo was taken, I hadn't yet made the cuts to connect the mainline run or grade from the tunnel portal to this point. So you can see there's an 1.25 inch difference in elevation. Here are a few initial photos of how the connection is laid out, with some photos of the initial supports. There are more that I added after these photos were taken to stiffen it up, but this just gives you an idea of how this final piece was connected up. Note how I deliberately offset this last piece of sub-roadbed from the layer below to keep access to the yard ladder and turnouts free and clear from above. The sub-roadbed for the main line, exiting the mainline portal, was cut directly from the large plywood sheet after it had been fixed in place to confirm its location. Once that was done, the screws were removed and the sheet was shifted over so that the track still inside the tunnel could be finalized to match where it should be upon exiting the portal. At the same time, while the plywood was removed, I took the opportunity to trim the column supports to lower the top elevation of the plywood to match the ones that had been cut on the other side, lowering the overall elevation to match where it goes through the wall. Once all that was done and all the screws put back in place and everything was solid once again, I was horrified to find that the alignment on either side of the tunnel portal didn't match up. I can't explain, I don't understand how I screwed that up, but I double checked to make sure everything was square. I double checked the both vertical and horizontal plumbness of the sub-roadbed, but in the end I realized I have to take it all apart again or try and realign the track from the side. I also took the time to make sure that there were no dips, vertical dips in the alignment. And I used the string method as I did in the last video, but this time checking for vertical alignment rather than horizontal alignment. With the string held in place by the yellow clamp on the left, the large C clamp on the right was used to raise or lower the riser until there was no gap between the string and the plywood. This ensures a smooth grade. Although challenging, I was actually able to remove the track nails and the small nails holding the cork down in place and reset it, straightening out the alignment to match where I had drawn it on the actual piece on the other side of the tunnel portal. So no harm done, just a minor temporary headache. The very last piece of the mainline puzzle was this short section that bridges the gap between the portal section and the curving mainline that wraps around the upper level. It was cut from this larger section that bridged the gap between the two large pieces of 4x8 plywood. And here you see a view of the two long splice plates that were used on either side of that section to make the joint. It was at this point when I was using these triangular shims to hold these splice plates in place temporarily as I was screwing them in, that I realized I had an opportunity to raise or lower the upper level just slightly to make sure I've got a proper bowl shape in the yard above. I experimented with different adjustments to the elevation, just very slight adjustments, to see if I can get my most free-rolling car to start moving on its own and see where it would end up if left to its own devices. Will it stop or keep running at the end of the track? Fortunately, the rest of the tabletop is flat, so it does eventually come to a stop rather than running through the turnouts at the other end of the track. I experimented by giving the car a little kick faster and faster each time, but it always came to a stop. Coincidentally and fortunately, there is zero crossfall with the elevation that I chose. Notice the bubble, perfectly level. With the elevation set, I set out to create a riser that would fit between the two layers of plywood to fix and hold in place the elevation selected. Because there is a slight variation in grades between the two pieces of plywood, I did need to shim one side of the gap between the riser and the upper plywood. I realized after that there are many simpler ways to have done this. Here's an example of an L bracket in 1x2. You could use a 1x2 crosswise as well with glue. And I continued to use this method as I proceeded along the main line as the main line and upper level grades converge as the main line moves further and further along. The original track plan that you've seen thus far has a split lead arrangement with a switching lead that doubles as a locomotive servicing area connected to most of the industrial sidings, plus a separate arrival departure lead with a shared track in the middle connecting to both leads. And this is what it would look like on the layout. Note that you might find some of these visuals a little bit out of sync with the rest of the video thus far, because I had to do a lot of these mental gymnastics before I actually cut the plywood. So forgive me if it's out of order. This will lead to the next section where I talk about much more in the way of track alignment changes and opportunities. I am generally not a fan of curved turnouts. I do have one on the original layout. It happens to be in a hidden location leading to one of the staging yards. It has on occasion given me trouble. But there's a time and a place where they can be very useful, and that's when you're cramped for space and you want to maximize track length. So here is a different arrangement for the yard throat using an extra or leftover Walther Shinohara turnout with a 28-inch inside radius and 32-inch outside radius. One of the advantages of this arrangement is that it allows all 4 of the yard tracks to be connected to a single lead. This lead, however, is the arrival departure lead, and it is on a slight grade beyond the point of switch of the curved turnout down the 1.25 inches or so that connects to the main line that heads back to the rest of the layout. This arrangement still allows for the track that heads off to the locomotive servicing area to also be used as a switching lead. However, there's only access to 2 of the 4 yard tracks rather than 3. This next option fully maximizes the track capacity on all 4 yard tracks by curving the lead, essentially running through the reverse left hand of all the turnouts in the ladder. It thereby reduces the access from the locomotive servicing quote-unquote lead to only 1 of the 4 tracks. Here's another view of option 3, but with all of the other turnouts roughly in their position that they would be once the layout is completed. Which option do you prefer? Let me know in the comments. Now, you may not have noticed, but when I was laying out the turnouts, I made an error. This ladder at the back end of the yard, I guess I was lazy. I just placed the turnouts one behind the other and was drawing pencil lines to identify locations of industrial sidings, etc. And I couldn't figure out why it wasn't matching with the plan. I thought I had carefully measured the locations of the studs in the wall, and I knew where the tracks were going to pass through, but for some reason the tracks were heading right into the studs. So it turns out it was a rookie mistake. The number 6 turnouts have a 9-degree frog, and by placing them end to end with a 2-inch track spacing, that doesn't work. So in fact, for a 2-inch track spacing with a 9-degree frog, the turnouts have to be spaced about 1.5 inches apart and not butted up one next to the other. So here's what it really should look like, and you'll see the result of that proper alignment is that it actually rotates the ladder slightly to the right and away from the studs. It does, however, mean that the spur that's going into the building on the far right on the layout diagram needs to pass through the wall just to the right of the other stud. This was always in the plan. I just had never opened up this section of the wall because I mistakenly thought I had gotten away with not needing to do it. Not the end of the world, but this opened up a new issue in that the cold storage industry on the other side of the wall has some stabilizer sections of styrene. I'm going to have to trim them back so they don't get hit by cars passing through the wall at this location. So this is as far as we got in terms of supporting the upper level sub-roadbed by the mainline sub-roadbed below. We did this to make sure we had no obstructions in the Helix staging yard below. Although we didn't talk about it much in this video, there are obviously 3 additional cuts that were made in the top plywood to join the mainline roadbed to the line that runs through the wall to the existing layout, as well as to create a grade between the main line and the upper level industrial area. So that's why you see those 3 cuts in the plywood. So why did we leave this piece unfinished? Well, that will be the subject of the next section in this video, where I'll give you guys a chance to comment on whether you think this should stay or whether there's another way of getting into the paper mill area. Before we get into that, I just want to touch on the subject of maintenance access. You can see from this photo that I've created 2 major maintenance areas, one in the distance and one much closer to the camera. This first area allows you to stand up behind the backdrop and access the turning loop below, as well as the ladder, turnouts, and turtle-switch machines for the bottom end of the staging yard. An additional section was cut away from the top level plywood to make for a rather large area to stand up within the Helix behind the backdrop to basically be able to access anywhere inside the Helix with as few as possible obstructions. And here's a 360-degree view of what you can access from inside the Helix, partially on your knees, I guess, underneath the finished area above, but partially standing up as well. And here's a final walk around the whole layout to give you a sense of where we are at this point in time. The next stage will be to start putting some actual roadbed down, cork roadbed, and install some of the track. I am going to continue to add the odd brace or riser here and there to firm up any spots where I think the span is too great. But for the most part, the heavy bench work is done. And now, as promised, an opportunity for you to participate in a possible further evolution of the track plan. Let's dive in. This is the most recent plan that I have shown you. We'll call it the base plan, and you'll see how things evolved from here. This is option 1, and the only differences between it and the base plan is the backdrop curve, which I've increased the radius from 6 inches to 10 inches because I think 6 is too tight to bend the masonite. Plus, I don't think it looks as good with a sharp curve. So that's what you see there. It's common to all the options you're going to see from here on in, so we'll just mention it here once and then we won't talk about it again. Also, the paper loading spur, I've changed from being parallel to the line that runs through the backdrop to something that's more parallel to the yard. So again, that's something that you'll see in all the options going forward for consistency. I mean, I can still play with that idea, but I like this better because it doesn't have as much interference between the semi-trailers that will be backed up to the building for loading paper with the track. So it gives me something between the 2 tracks, and the trucks will also act as a view block to the hole in the backdrop. I've called this next option 1A because I didn't want it to be confused with option 2 that I showed you earlier in the video. It's just a shuffling of the number 6 turnouts at the bottom end of the yard ladders and switching leads. It just changes the number of tracks that the lead to the locomotive servicing area has access to. So I've skipped option 2 because that's the one you saw earlier in the video. And now I'm calling this one option 3, which is the same as what you saw earlier in the video as option 3. So this is essentially putting the entire yard onto one ladder using a curved turnout. No other differences. I'm getting used to this idea, and so you're going to see this in all the options going forward. It's not perfect because the yard lead is now going down a 1% grade around the long curve towards the backdrop. We will talk about that more a little later. I'm calling this option 3C because it's essentially option 3, but I've swapped out the locomotive service area with a small coal unloading shed. There's enough length on this spur for probably 10 or 11 50-foot coal hoppers, which means that assuming there's a car puller at the shed, I could spot 5 cars for unloading and they'd be pulled through one at a time to unload, and they wouldn't need to be double switched. Like many of my track planning ideas, this was influenced by a prototype aerial photo. This is one of several paper mills that I've researched and used as a source of inspiration for my track planning for my new layout extension. This one is in Spring Grove, Pennsylvania. It's Pixel Specialty Products. Well, let me just zoom in here and show you a few things. You see here quite a distance from the actual mill itself is where they bring in logs and they turn them into chips, and they send them via an overhead conveyor across the river, across the main line, into the wood chip pile. So this is similar to the thinking in my layout, where the chips are not brought in by rail, but they're stored nearby. Similarly, this facility has a coal pile as it's using coal as its primary source of fuel for the power plant. Interestingly, Norfolk Southern here is bringing in cuts of cars, 2 cuts of 15 cars at a time. You see the one on the bottom here is loads, and the one that's in the facility here, it's almost all empties. They have 1 car left to unload and they're pulling it through. And the unloader is very, very small. And there's no direct connection between the unloader and the coal piles. What is really going on here, as you can see it here, there's obviously an auger underneath the ground, and it comes up through here into this building, and from there sent via conveyor to the coal piles, and from the coal piles over to the power plant. So really an opportunity here for me to try something different and add a prototype flavor to the layout that I'm planning. Now, one of the other interesting points that I want to show here, we're going to use Street View, is how tracks enter the facility. This is one of several locations where tracks enter the facility. But you'll recall on my layout drawing, there's this location where tracks go in between buildings and head through the backdrop. So I thought this is a neat idea where I'll use corrugated materials to join buildings to kind of block the view through the backdrop. And I'm going to have the buildings placed a little bit closer together so it really camouflages where these tracks pass between buildings and through the backdrop. Moving on to our next option, which I've called 3CY, only to show the addition of a Y turnout behind the backdrop, which would allow trains to enter or arrive into the mill yard through the slot between the 2 buildings. I thought this was an interesting idea to explore. The only catch being that when the mill switcher is switching out some of these industries, the track through the backdrop is a switching lead or pullback, and it might nose into the other town through the backdrop and interfere with switching operations there. And it wouldn't look prototypical, obviously, to be coming out into the other yard. It could be theoretically many, many, many miles away. Option 3CY, X meaning there's no longer a downgrade to the mainline or a second mainline connection to the yard. This is compelling because we wouldn't have to be switching on a 1% grade and there'd be no risk of cars running away down the hill. The downside is the switch lead is probably no more than 5 feet long. It would also make it somewhat awkward to arrive trains of any length, but especially to build the outbound trains heading back through the backdrop. Next up is option 3CA, with the A meaning an alternative location of the coal unloading shed. In this case, the shed is placed right at the backdrop, which effectively doubles the number of cars that can be spotted for unloading, 10 or 11, maybe even 12 cars. It also eliminates the need for any structure associated with coal unloading other than the shed, although it's not clear how this would be blended into the backdrop. Would I show large coal piles, etc. Now this is where it gets really interesting, or silly, depending on your perspective. I realize that I can now connect up both ends of the coal unloading track, and I could run unit trains through the backdrop and through the coal unloading shed and send the trains on their merry way back to the rest of the layout. And this last option, similar to a couple previous, we simply remove the second mainline connection and have a stub-ended yard lead at the same elevation of the coal unloading spur. So there you have it, lots of alternatives and ideas to think about. Please let me know what your thoughts are, what you like, what you didn't like, and if I get enough responses, we'll talk about it on our next video. As always, thank you for watching. If you enjoy layout improvement videos, here are a few others that you may find interesting. If you're not already a subscriber, you can click on the logo on the top right-hand corner of your screen.